A little while ago, we made a compilation video where we answered your most pressing dog questions. But we here at SciShow are pet non-partisans. So naturally, we needed to make a compilation dedicated to our feline friends as well. Let's start with the oldest question first. It's often said that we humans didn't domesticate cats. Instead, they domesticated themselves. And there's some truth to that. What's less often repeated, however, is the hypothesis that it happened more than once. Here's Hank to explain how that's even possible.
Cats. We know that they like to chase lasers and lick their own butts, but there is a lot that we don't know about cute little Whiskers, like where her cuddly domestic ancestors came from and when she evolved from wild animals. We used to think that the earliest historical evidence for domestic cats was from ancient Egypt, like art and mummified remains from around 4,000 years ago. But now, some clues are pointing to domestic kitties older than that from separate places across the globe. The oldest probably domestic cat skeleton we've found was in 2001 on the island of Cyprus in the Mediterranean Sea. Scientists guess that this cat lived around 9,500 years ago, which makes sense historically. That's after people started farming in the Fertile Crescent, that not totally desert region in parts of Western Asia and Northern Africa. Farming means you have to store extra crops somewhere, and piles of tasty grain attract rodents. And for hungry cats, that's an all-you-can-eat buffet. So one hypothesis is that feral cats might have started snagging some meals and getting cozy with humans. Humans were happy to have them too because they took care of the pests and were fluffy and cute. By this time, we think humans had domesticated other animals like dogs, cattle, and sheep, so adding another furry friend wouldn't seem all that unusual. And we think this cat from Cyprus was a pet for a couple of reasons. First of all, Cyprus is an island with no native cats, so someone must have brought them over on a boat, and if they weren't a little tame, that would have been a scratchy, panicky animal mess. Like, you might know how hard it can be to get an uncontrollable kitty just to the vet and back. Plus, the cat was buried with a person, presumably its owner, and surrounded with carved seashells. Wild animals wouldn't get this special treatment, and if the cat was a meal, its bones would have been separate and probably scattered. All of this evidence lines up with a study published in the journal Science in 2007, which looked at the genetic origins of domestic cats. Those researchers found that our feline friends are most closely related to the wild cat Felis sylvestris, specifically the Near Eastern subspecies. Your eyes, also, if you look at this cat, will back this evidence up, because they look a lot like domestic cats. So lots of signs point to domestic cats splitting off from their wildcat cousins in the Fertile Crescent. But hold on, some other scientists discovered probably domestic cat bones in 2001 in an ancient millet farming village in central China. A close computer analysis of jawbone shapes showed that these cats weren't related to the wildcat at all. Instead, they were a kind of leopard cat, which is in an entirely different genus. From small animal tunnels throughout the excavation site and ceramic containers that looked like they stored grain, the researchers were pretty sure that this village had a rodent problem. And by looking at the carbon isotopes in cats' bones, it was clear that they ate lots of small animals that ate lots of human-grown millet. This was the first convincing evidence to support the domestic cats eat pests that eat grain hypothesis. But this domestication happened in different kinds of cats around 5,300 years ago on the other side of this huge landmass. So, what's the real story? The Middle Eastern or the Chinese domestication of cats? Well, there's no reason to think that domestication couldn't have happened twice in two separate places with two separate cat species when people started farming grain. But remember, genetically, all of our modern cats seem to be descended from the wildcat, not the leopard cat. Maybe the domestic wildcats were just snugglier and had a leg up to win our favor. See, domestication leaves its fingerprints in an animal's genome. So even though any cat person will joke that their cats are too independent to really be considered domesticated, we can look at these genetic fingerprints. A 2014 collaboration between a bunch of American universities took a close look at the domestic cat genome using 22 different breeds from different places. The study found recent changes in genes that controlled the development of the cat's nervous system. These genes could play a role in how domestic cats, for example, behave less defensively in new situations and can change their behavior in response to rewards. In other words, compared to a wildcat, Fluffy is genetically more likely to walk up to you with a friendly headbutt and beg for treats. This could explain why our cats are extra snuggly. The ones that got along best with humans could take advantage of our rodent pests and table scraps and survived to pass on their genes. So in a way, cats did domesticate themselves, and it seems like they did it more than one time. Which kind of means that the rise of cat videos was practically inevitable.
We like to think that we've contributed to the vast library of cat videos, and maybe even added some science to the mix too. Next up, cats have lived with us for thousands of years. but they still share plenty of features with their wild counterparts, like the keen senses of a nighttime hunter. That's why they do that faintly alarming laser eye thing when you get up to go to the bathroom at 3 a.m., as Michael vividly explains.
It can be terrifying to wake up in the middle of the night to a pair of glowing eyes staring at you from the darkness, only to realize that it's just your cat. Or is it? Lots of animals, including alligators, fruit bats, and dogs, all have a shiny structure in their eyes that gives them better night vision, which also causes this creepy glow. The layer of tissue at the back of your eyes is called the retina, and it's made up of special light-sensitive cells. Light that hits those cells gets turned into an electrical signal that's sent along the optic nerve, which sits behind the retina. That signal travels all the way to the brain. And light that misses those cells isn't turned into a signal, so your brain can't detect it. Many species across the animal kingdom have this same basic eye structure, from reptiles to birds to other mammals like cats. One way animals have evolved to see better is to have more of these light-sensitive cells in each eye. Humans, for example, have over 95 million of them per retina. But a lot of animals, especially nocturnal animals whose eyes have to work well at night, have another way of detecting more light. They have a structure called the tapetum lucidum, which is Latin for bright tapestry. It's a layer of tissue that sits behind the retina and acts like a mirror. The tapetum lucidum reflects light that goes through the retina back at those light-sensitive cells, giving them another chance to detect it. But some of that reflected light flies back out of the animal's pupils, which is what makes it seem like their eyes are glowing. The color of that glow, also called eye shine, depends on what the tapetum lucidum is made of, and different critters have different highly ordered molecules or fibers that create a reflective surface. Some fish use guanine, one of the chemical building blocks in DNA, and have white eye shine. Sheep have collagen, which also provides structure to muscles and skin in lots of animals, which leads to a blue or green glow. And cats use riboflavin and zinc, among other molecules, and the amount of zinc does a lot to determine how yellow or green or even blue their eye shine is. So your kitty's eyes aren't actually like little flashlights, they're just reflecting some of the ambient light in your room. But if they start glowing red and shooting laser beams, you should probably run.
We ought to note that none of our cats have displayed this behavior to date. There's still time, though. But while your cat may think they're a fierce, majestic predator patrolling the savannas of your living room, they have more in common with smaller, wild cats than lions and tigers. They can't roar like big cats can, for example. They can purr, though, and that seems like more than a fair trade. Here's Hank to explain why it's usually one or the other.
I have a cat. Her name is Cameo, she is adorable, and recently she peed inside of a potted plant. But can you imagine how amazing it would be if she could roar while peeing inside of a potted plant? She'd be like, give me some treats, and then like, ferocious roar. It would be so cute. But domestic cats cannot roar. Only 4 species in the cat family can: lions, tigers, leopards, and jaguars. Here's the weird thing though. Zoologists are pretty sure that those 4 species of cats can't purr. So even though my cat can't roar, the reason probably has a lot to do with the things in her throat that let her purr. Now we still aren't, this is amazing, totally sure how cats purr. There is no like purr box that we can locate in a cat, and no one's ever stuck a purring cat into an MRI to find out exactly what's happening. But we've known for a while that it probably involves the larynx, aka the voice box. Back in 1834, a British zoologist named Richard Owen noticed that there was an anatomical difference between the cat species that purred and the ones that roared. Roaring cats had a more flexible hyoid. The hyoid is a structure that supports the tongue and larynx. In humans, it's horseshoe-shaped. It's basically the first bone under your chin in the front of your neck, although you shouldn't be able to feel it from the outside, so maybe don't go squeezing up around in there. On the murder shows, it's how they know people got strangled and when they got killed. They're always like, the hyoid's broken. That's how we know that the murder was the squeezy neck kind. In cats, the hyoid is more of a hook that hangs down and connects the back of the skull to the front of the larynx and the base of the tongue. In most species of cat, including the domestic cat, the hyoid bone is very bony. It's said to be completely ossified, meaning that it's fully hardened bone. And all the cats that have a completely ossified hyoid can purr, but don't roar. The cats that do roar don't have a fully ossified hyoid, meaning that it hasn't fully hardened into bone, so it's a lot more flexible. The tissue is more like the ligaments that normally connect bones to each other. Owen thought that that flexibility was the key to roaring. Roaring is a low, deep, resonant sound, so cats need long vocal folds to do it, just like like people with longer vocal folds have deeper voices. And Owen figured a more flexible hyoid was what let cats' vocal cords stretch enough for them to roar. For a long time, pretty much everybody agreed with this idea. They also assumed that hardened, bony hyoids were the reason that all of the species of cats that couldn't roar could purr. But there is one exception, the snow leopard. Snow leopards don't have a fully hardened hyoid. They have the more flexible kind that lions do, but they cannot roar. And even though we've known about the snow leopard exception since at least 1916, scientists didn't really question the hyoid idea until the late 1980s. That was when researchers realized that there is another difference between cats that can roar and cats that can't. Roaring cats have thick pads of tissue in their vocal folds. The pads make their vocal folds longer and heavier, which allows them to vibrate slowly and make a lower-pitched sound. Only lions, tigers, leopards, and jaguars have these pads, with no exceptions, not even snow leopards. So roaring isn't entirely about the hyoid bone. Sure, the extra flexibility might help, but they also need that extra tissue that our domestic cat friends don't have. These pads also help explain why cats that roar can't purr. When cats purr, they vibrate their vocal folds at about 26 times per second. There seems to be some mechanism in their brains that controls the vibrations. As they inhale and exhale, the vocal folds open and close, which is what makes the purring sound. It's like how you can make that motorboat sound by vibrating your lips, except they do it inside of them with their vocal folds. But the extra padding that allows lions, tigers, leopards, and jaguars to roar would dampen the constant vibrations that they would need to purr. The females of those species do make purring-like noises when they're in heat, but those noises don't seem to be quite the same as true purring. They're closer to a growl. So, my cat can't roar because her vocal folds just aren't shaped for it, but she can purr, and that's pretty dang cute, and I like it.
Me too, Hank. Me too. Slightly less majestic is the habit cats have of being completely blind to a treat that's right in front of them. Like, you shake a treat bag and they'll come running, but once they get there, they sometimes just search around and give you this really disappointed look like they can't find their snack. You know, it's right there. It's right there, okay? This happens because cats' eyes work differently than ours, and they actually are literally blind to that piece of freeze-dried chicken an inch away from their nose.
Cats are masterful predators, capable of spotting prey from meters away in the dead of night. But place a treat in front of them, and they're basically blind. But why? How can such good hunters be so lousy at seeing what's right in front of them? It turns out that their vision isn't always amazing, since being able to see so well at night comes with some drawbacks. Cats are crepuscular. That means they're most active at dawn and dusk. As a result, their eyes have evolved to see best when the light is low. For one thing, their eyes are huge. They're nearly as large as human eyes, even though their heads are less than half the size of ours. Their slit-shaped pupils also have a greater range of size. Human pupils can dilate to 15 times their smallest size. Cats' pupils can dilate by 135-fold and get even wider than human pupils to let in a lot more light. The parts of their eyes that let in and focus light, their corneas and lenses, are also proportionally larger, which ultimately means more light reaches the light-sensing tissue in the back, called the retina. And they have an extra reflective layer behind the retina called the tapetum lucidum, which reflects back any light that reaches it, giving the retina a second chance to catch what it missed. Special cells in the retina called photoreceptors are what actually sense light. And like us, cats have two types of photoreceptors, rods and cones. Rods work best in low light, but don't sense color very well. Cones are used in color vision, but they only really work if there's a good amount of light. Cats have almost 3 times as many rods as we do, but only 10% as many cones. That makes for killer night vision, but in bright light, those rods become overloaded and can switch off completely. That leaves the handful of cones to do the heavy lifting, which makes for some pretty paltry daytime vision. And those huge eyes? They're really hard to focus. To zero in on a nearby object, you need to bend that hard part of your eyeball, called the lens, enough to reshape how light enters your eye. You have muscles in your eyes that can do that quickly when you need to focus on something close up. But the massive lenses in cat eyes just aren't as flexible, so they don't bend as well as yours do. Ultimately, this means that cats simply can't focus on anything closer than about 25 centimeters to them. So when you hold a treat in front of your kitty's face, all they see is a washed-out blur. Luckily, their sense of smell is twice as sharp as yours, so if you hold that treat long enough, they're bound to sniff it out eventually.
That doesn't explain the disapproving look, though. But actually, we can explain that too.
If you're a cat person like me, you've probably seen your furry friend looking disgusted with you? There's this face they make, like with the wrinkled up nose, the curled back lip, and the open mouth, that looks like they're just absolutely revolted. Good news, your cat doesn't actually think you're gross. Or if they do, that face isn't how they show it. That sneer is actually what's known as the flamen response, and it gives cats and other animals like horses, llamas, dogs, and giraffes a supercharged way to smell the environment around them. While it might look like cats are expressing their distaste, what they're actually doing with that face is sniffing using a specialized organ called the vomeronasal organ. It sits kind of underneath the nose in the roof of the mouth, and it's actually connected to the mouth by small fluid-filled ducts called nasopalatine canals. If you look in your cat's mouth, you can even see the ends of these. They're behind the sharp incisors. So good luck getting a cat to sit still while you, take a look at the inside of its mouth. Anyway, because of the fluid in these ducts, scents don't passively drift up there. So to sniff, airborne scents have to be taken in through the mouth, dissolved in fluid, and then pumped up until they come into contact with the organ's sensory cells. And that is where that funny face comes in. When a cat or giraffe or horse pulls back their lips into the grimace of the flamen response, they're opening up those canals and starting the pumping action to take a deeper whiff. They could just rely on their nose, but the vomeronasal organ has its own set of chemical receptors so it can smell different smells. This system is primarily used to detect scent signals from members of their own species, though different animals and even different sexes of the same animal can use this secondary smelling system in different ways. And that might explain why people tend to associate the flamen face with cats and horses more than with dogs, even though all of them can sniff this way. In case you're wondering though, you cannot. Humans lost all of those nasopalatine ducts a long time ago, and while there are some remnant cavities where your vomeronasal organs once were, it's been a while since they could detect anything. Which is all to say, don't worry if your cats are making weird faces at you. They don't hate you, but they might think you smell.
I'm pretty sure they'll get over it. And maybe you can make it up to them with some catnip. Not every kitty loves the stuff, but those who do are just really cute when they swoosh their faces in it and throw their toys all over. Still, many cat owners are puzzled by their response to this stuff. I mean, what's the big deal? Fortunately, we do have some ideas about the chemistry of catnip and why it makes whiskers go bananas.
Ever seen a cat dip into some recreational catnip? It usually makes the cat act a little strange. It rubs up against the catnip, rolls in it, and paws it. It's clearly enjoying itself. And all because of a compound that's a little too similar to its natural biological signals. Catnip, aka Nepentecataria, is a plant that's a member of the mint family. When cats react to catnip, they're really reacting to an organic molecule released by the plant known as nepentolactone. Nepentolactone is made up of two connected rings of mostly carbons, and the plant uses it to repel insects like mosquitoes, ticks, and mites. But most cats are attracted to the stuff. They'll first start sniffing the catnip, then lick and chew it, sometimes rubbing their cheeks and chin or even their whole body against the leaves. Some cats will meow or even drool. I mean, they're obviously into it. But the effects only last about 15 minutes. After that, catnip will have no effect on the cat for anywhere from 30 minutes to a couple of hours. So what's going on? Well, researchers think nepentolactone is similar to a cat's natural pheromones, the molecules it uses to communicate. Once the compound gets into the cat's nose, it bonds with the same receptors pheromones do, and the cat's brain gets a signal that basically says, lots of pheromones over here. The catnip stimulates three main areas of the cat's brain: the olfactory bulb, which processes scent, the amygdala, which is involved in emotions and decisions, and the hypothalamus, which is in charge of sexual response, among other things. The last one helps explain why cats exposed to catnip will often roll on the ground like a female cat in heat. It's also probably why kittens don't usually respond to catnip until they're sexually mature, when they're around 6 months old. But not every cat does respond to catnip. Only about 50 to 70% of cats do. It's genetic, and scientists are still looking to identify the gene involved and learn more about what exactly is going on in the cat's brain when it's reacting to catnip. Some big cats, like lions and jaguars, also respond to catnip, but other animals don't use the same pheromones or have the same receptors, so catnip doesn't affect them. And it's not just catnip. Other plants will also attract cats, probably for similar reasons. They produce compounds that act like cat pheromones. Silvervine, for example, produces a cat pheromone-like molecule called actinidine. In general, these cat-attracting plants seem to be perfectly safe for cats. They aren't addictive, but a cat that's often exposed to the stuff can become less sensitive to it. So, if your kitty likes catnip, it's totally okay for them to indulge once in a while.
Once your cat comes down from their catnip-induced high, they might settle in for a nap, in which case they might exhibit one of the most objectively adorable cat behaviors, making biscuits. Not literal biscuits, that would probably be a health code violation somehow. I'm talking about kneading, the cute paw smush thing they do when they're getting all cozy. Here's Hank to tell us why they do it.
So you know when your cat comes up to you and it starts to look at you and it seems happy, it's purring, and then it tries to make biscuits out of your body? It's so cute. It's cute because Kitty loves you. But it's also painful because Kitty's love is made out of little tiny knives. Why does it do that? Why? There are theories. Of course, some animal behaviorists believe that it's another way for cats to mark their territory since paws have scent glands in them. The most popular theory, however, is that kneading is a neotenic behavior, a juvenile trait that is retained in adulthood. Because kittens knead their mothers' bellies to stimulate milk production. This would explain why some adult cats also suckle whatever it is that they're kneading. However, adult wild cats do not knead. So, why have domestic cats retained this trait? Well, neotenic behaviors are most often found in domesticated animals, like house cats, partly because over the millennia, humans have selected for traits that make animals more social, less aggressive, and generally nicer to be around. But the animals have probably also held on to some of their more social, baby-like behavior, just because it serves them well when they're around people. Like, I don't know if you've heard this, but wildcats are not super social. They don't come up and cuddle so much as just try and eat your flesh. Felis sylvestris, the ancestor of all domestic cats, is a solitary hunter that only socializes with members of its own species when it's time to breed. So wild cats only develop social behaviors for two situations. One is, hey baby, why don't you come back to my burrow and we can make a little something something. And the other is caretaking behaviors between mother cats and their kittens. Unlike wild cats though, domesticated cats have a lot of social behaviors as adults, because they're not wild loners anymore. They have us to cuddle with, treats out of, and demand food from. So their innate tendencies for snuggling with mom and hitting on the lady cats are put to good use on us. Hence, kneading, originally a behavior that kittens needed to survive, is now a way for adult cats to show that they trust you and feel safe. And if you had a soft pelt like mom, you wouldn't feel so much of the little knives.
There's another way to help Kitty feel nice and safe. It's corrugated, it's recyclable. It's a cardboard box. It turns out, if I fits, I sits, reflects some pretty ancient feline instincts. Here's Michael to tell us why cats love boxes so much.
If you have a cat, or have ever spent much time on the internet, you know that cats like to sit in boxes or any other small container. Adorable, no? If it fits, they sits. But have you ever wondered why they do this? Well, for one, it helps their anxiety. I know, considering they sleep 12 hours a day, they don't really seem like anxious animals, but cats experience stress like any other mammal. And when they're sitting in a box, cats feel like they're in a protected place where they can observe and hunt without worrying about being attacked. This makes sense since cats are ambush predators, meaning they're always looking to surprise their next target. To better understand how boxes help cats calm down, one study published in the journal Applied Animal Behavior Science observed a group of cats that had just arrived at a new animal shelter. New environments can be difficult for cats, so stress levels were pretty high. And scientists were able to rank the cat's anxiety by looking at factors like their activity levels and their ear and tail positions. This system is known as the Kessler and Turner Cat Stress Score. Now, when some of the cats were given boxes to hide in, their stress levels went way down in only 3 days, and the effect was observed in nearly all of the animals with boxes. For comparison, the cats who didn't get boxes eventually reached the same low level of stress, but it took them 2 weeks. So, especially in high stress situations, it's important for cats to have an enclosed space to retreat to and feel protected. This is also true of large cats, like tigers and jaguars, except instead of hiding in your latest Amazon box, they'll hide in trees, caves, or other concealed spaces. But there's another reason cats like boxes so much. Apparently, Our houses are too cold. While you might enjoy a comfortable 24 degrees Celsius, cats prefer much warmer temperatures, between 30 and 36 degrees, according to a study by the National Research Council. By curling up in a cardboard box, cats can trap some of their body heat to make up a few of those degrees. That's also why cats like basking in sunlight or curling up on top of your heating vent. So if you have a kitty at home and you want to keep cat stress at bay, just make sure they have a nice cozy box to sit in.
Thanks for watching this extra fluffy compilation. Please pet all your cats for me and tell them I love them. And thanks to our patrons who help us make videos answering questions like these. If you're interested in lending a hand, check out patreon.com/scishow.